According to the theory of evolution, the origin and development of the universe and all its systems can be explained solely on the basis of time, chance, and continuing processes. All living things have arisen from a single-celled organism. A second and opposing worldview is the concept of creation. According to the theory of creation, everything in the universe has come into being through the design, purpose, and deliberate acts of a supernatural creator. That means this creator created the universe, the earth, and all life on earth, including all types of plants and animals, as well as humans. On today's edition of Origins, vestigial organs from 100 to none.
Hello, my friends. Welcome to Origins. My name's Don Chapman, and it's my privilege to be your host. Origins is a forum where we take the evidence of science and we use it to confirm the truth of creation. And we do that by getting some really good guests who come in and share with us from their particular area of knowledge and help us to understand what's happening in the scientific world and how it relates to creation. And we have a great guest with us today. We're really privileged to have Dr. Jerry Bergman with us. Dr. Bergman, listen to these things he teaches at school. He teaches in the field of biology and genetics and biochemistry and anthropology and geology and microbiology and every other area of science as well. Dr. Bergman, it's awfully good to have you with us today.
Thank you. It's very good to be here.
Thanks for being with us. Now, just so the folks know, you were telling me, how many degrees do you have?
Well, I finished my 9th degree recently.
You can get part-time work as a thermometer. I mean, you have all those degrees. You've got it. You've really got it going. You've been studying all your life, haven't you?
I've always enjoyed school, especially in the area of science, biology, molecular biology, and so on.
Now, when did you come to a point in your education that you got to thinking, you know what, this is confirming the reality of a creator and not showing that man came from nothing?
Well, that's one of the areas that was important in my becoming a creationist from a Darwinist, which at one time I was an evolutionist, was the study of vestigial organs. Because I realized that the predictions that Darwinists made 100 years ago turned out to be wrong.
Tell us about vestigial organs. What does that mean?
Well, a vestigial organ is an organ that has no function in us, for example, in human vestigial organs. And at one time, there's believed to be over 100 vestigial organs in humans that had no function. And it was believed that these were part of our evolutionary heritage. We got them when we were apes or when we were mammals or reptiles or fish. And so they're evolutionary leftovers, they often call them.
Okay, and how many organs are there left in the human body today that have no function?
Well, there are none. They're all we recognize now, they all have a function. Many have a very important function.
So I want to affirm the fact that the assumption of evolution was based on ignorance. It was a lack of knowledge, not knowledge, that made them believe we had organs that had no purpose.
They argued from lack of knowledge, right.
Okay. Now, today you're going to talk about some of these so-called vestigial organs and show us what their function is that right?
Right. I'll cover several.
I would love for you to do that.
Okay.
Show us what you got, my friend.
First, I'll mention that this talks about Wiedersheim, who was one of the early anatomists, and he wrote a book which he included about 86 vestigial organs at that time. And now, of course, vestigial organs are, even today, by Darwinists, seen as major evidence of evolution. And, of course, this was seen as important because why would God make an organism with all of these useless organs? Why would God make a human being with 100 organs that had no function? That didn't make any sense.
So this was a major source of, quote, proof for the evolutionist.
Right. When you look in a biology book under the section on evolution, typically they list 5 or 6 proofs of Darwinism. And almost always they listed the vestigial organ argument. So it was not a small concern, it was a major concern. And it's still in many books today, by the way. And the first one I'll look at is the tonsils and the adenoids. And I like to talk about this because so many of us, or at least we know somebody, who's had their tonsils removed. And a lot of people wonder, well, why? Why do they remove the tonsils? Well, first of all, the tonsils are a group of lymphatic tissue that are found in the throat directly behind the tongue, or at least several sets are. And looking at the next slide shows us specifically where they're at. Here are the pharyngeal tonsils over here, and the palatine tonsils are over here, and the lingual tonsils are over here. So you can see they're scattered throughout the nasal and the throat, the pharynx area here of the body.
So they're part of our immune system, is that right?
And they're part of our immune system. They're often called the first line of defense against bacteria. And basically, when we have a throat infection, they are the structures that help us fight these infections and problems.
So a lot of times, they're not causing the infection, they're screening the infection, is that right?
Right, they're helping to fight it. It's kind of like in a battle, you've got a first line of troops. Well, they're the most likely are going to be slaughtered, but on the other hand, they're important in dealing with the battle.
So they're not a bad thing, they're a good thing.
In general, they're a good thing, although they can become too swollen, and then they block the breathing and the ability to swallow. And of course, when they become too swollen, then they have to be removed. But doctors are very leery today to remove them. They will not remove them unless they're clearly indicated that that's necessary. And the reason we assumed the tonsils were vestigial was because we did a lot of tonsillectomies and there didn't seem to be any problem after we did so. We removed the tonsils from a patient and seemed to do fine, seemed to have a normal life expectancy, and there wasn't a problem. And they first suspected the tonsils caused a problem when it was noticed that the tonsil size and respiratory infections were related. So you have a respiratory infection, the tonsils swell. Well, maybe if we remove the tonsils, the respiratory infection will go away. And that for a long time was believed to be the case. And when, of course, you have a severe cold, the tonsils swell. Sure. It seems to be part of the cold. And it was believed that tonsils could cause health problems. So they removed them, and of course, if the tonsils were infected, if you remove the tonsils, they're not going to be infected anymore because they're not there.
They're not there to be infected.
So you can't have a problem with tonsillitis when you have a tonsillectomy.
So does that mean the rest of your immune system has to pick up the load because this part's been taken away? Is that...
Right. Basically, the tonsils are a backup organ.
Okay.
The immune system is very complex, and you have many structures in the body that deal with fighting bacteria and germs and so on. And when you remove the tonsils, you have many other sets which will help deal with the same problem the tonsils were designed to deal with.
Okay.
And the fact of this information is now filtered down the medical community. In the 1930s, about half of all children had tonsillectomies, which is a lot of kids. In 1971, the frequency dropped to only 14.8 per 1,000 children. So it dropped enormously, and since then it's dropped a lot as well. So it's far, far less common operation today than it was 50 years ago.
And the reason for that is that the whole perspective or view of the doctors is different. Instead of seeing this as something that's unnecessary, so we'll just get rid of it, now it's seen as something with a function that is needed by each individual.
Right. Now they try to save the tonsils. They do what they can to save them. Yeah. It's like any other problem. They'll try to save an arm or a leg or another organ, and if there's nothing else they can do, as a last resort, they will remove that structure. And so likewise, the tonsils are also in that same category. They'll do what they can to save them, but if they can't, well, they've got to come out. My own interest, by the way, in vestigial organs was developed partially because of my own experiences. When I was 5, my parents took me to the doctor, and the doctor said, well, let's get those tonsils out. And I was curious as to why. So I asked the doctor, why? Because I didn't have any health problems. So why would you take them out? He says, well, it's better to take them out when you're younger. You can deal with the surgery better than when you're older. So I had them removed, and I went through the surgery, and lo and behold, not too long after that, they grew back. So doctors had to take them out again. And when I asked the doctor what they did, he said, well, they don't have any function. And I just found that hard to accept. Why would they be there if they had no function? You know, they must have some function. Maybe the answer is we just don't know what they do.
It's amazing. So later, your many years later, you're in medical school, getting the answer to refute what the doctor told you when you were a child. It's amazing how those early questions often form our lives, isn't it?
In my anatomy course, actually in the medical school, I talked about this and with my instructors, and they helped me see that indeed the tonsils do have a number of functions.
That's amazing.
The one I'll talk about now is the appendix. Appendix is commonly talked about because most people, even today, don't know what the appendix is. In my training, medical personnel, nurses, and people going in the medical field, students often ask me, what does the appendix do? Most of these people, now some are LPNs, so they do practice as a nurse, and they're going back for their RN degree. A lot of them don't even know what the appendix does. But actually, it has a number of very important functions. First of all, let me just describe where it is and its location. It's a small, narrow, worm-shaped tube. And it's actually fairly small, about 19 to 200 millimeters, so it ranges quite a bit in size. And of course, this depends on how large you are as a person, how old you are. Obviously, if you're quite a young child.
How many inches is 200 millimeters?
It's about, what, 4 inches?
So it can be anywhere from very small, 1/4 of an inch, to 3 inches, something like that. All right, I'm with you.
Okay. And here you can see a picture of what they call a vermiform appendix. Vermiform means it's shaped like a worm, and you can see it has a little bit of worm shape. In the next illustration is a better picture of it. You can see right here.
Oh, it's right.
And this gives you a better idea of where it's located in the body. This is the cecum. It's connected to the cecal area here. And you can see the ascending colon here, the transverse colon here, the descending colon here, the sigmoid colon here. And the small intestine will be right over here. So the appendix is right where the small intestine connects with the large intestine.
All right.
So it gives you an idea where it's located. And what does it do? Well, it has an important role in the immunological system. It helps protect the body against bacteria. And the appendix lymphatic tissue, which is what is inside of the appendix, is very similar to the tonsil tissue. And it's also very similar to lymphatic tissue found elsewhere in the body. And what does it do? Well, it helps protect the body against infections, especially during the early part of life. A lot of these structures, like the tonsils, shrink as we get older because they're important in establishing the body's immunological system. And once it's established, they're of far less need. And the lymphatic tissue in the appendix fights bacteria like Peyer's patch cells. Peyer's patch cells are patches of cells which are found in the intestines. And what it does specifically, because if you think of where it's located, it helps protect the almost sterile ileum, because the ileum is almost sterile or close to it, part of the intestine, from infections from the cecum region where the colon begins. And the large intestine, we know, has billions of bacteria. And normally fecal matter moves forward into the large intestine from the small intestine. Well, if some of this backs up, then you end up with bacteria in this area, in the cecal area, and this bacteria can cause a problem. Well, the appendix is right at that particular juncture, so it can help protect and ensure that the ileum remains largely sterile.
That's amazing.
And the next one I'll talk about is the thymus. And the thymus, I think, is an important one because this not only has an important function, but a critically important function. Without the thymus, when we're young, we'll die. It has to be there in order for the immunological system to develop. And the thymus was judged for many years not only vestigial, but harmful. So if it became enlarged, they thought, well, let's take it out. Or they would radiate it. So they'd use X-radiation in order to try to shrink it. And of course, it did shrink it. In fact, in some cases, they would actually remove it. But they found when they did that there were major health problems. So they realized, after a while, that the thymus not only is not producing the problem, but if you remove the thymus, it could cause other problems. And so as a result now, when they remove the thymus, typically you end up with a higher level of infections. So they realized this wasn't working, although a lot of people had died or became ill because of a thymectomy. So it didn't take long to realize that this organ had a function and it was there for a reason. And this is where it's located, to give you an idea. This is the sternum, or the breastbone. So it's right on, basically on the upper part of the sternum area. So it gives you an idea where it is. And often they call it the master gland, because it helps regulate and set up the immune system.
So it went from us thinking it was totally useless to now being called the master gland that's regulating our whole immune system.
Right, which is interesting because a lot of the vestigial organs are not critically important. They can be removed and it's not lethal, like the tonsils and the appendix and so on. You can have the appendix removed and the tonsils removed, and generally it doesn't cause a major problem as far as we know. And the reason for that is because there are many backup organs which take over the function of an organ that's removed. But the thymus, that's not true when you're young. When you're young, it cannot be removed without problems. And of course, it's more important in childhood, and as you get older, it becomes less important because the immune system becomes established. So therefore, it's less important. And the next one is a pineal gland, or pineal gland. And the pineal gland was long considered a useless appendage left over from when we were a lower form of life, specifically reptiles. So they looked at the pineal gland and they said, well, this proves that we were at one time reptiles, because reptiles have also a pineal gland, but it serves a different function than ours does. So this was seen as good evidence that we evolved from reptiles. And now we know the pineal gland is an active member of the body's endocrine gland system, especially during adolescence, for example. It helps regulate the sleep-wake cycle. It helps control the beginning of puberty, and so it has a number of very important functions. And this is where it's located, right here. This is the front of the
center of your brain.
So it's more or less towards the center, right? This is, of course, the frontal lobe and parietal lobe, the occipital lobe, and right in the middle area you can see is the pineal gland. And here's another picture. You can see it right here. And here's the pituitary, which also at one time, by the way, was felt to be vestigial. And what does it do? Well, it produces melatonin. And you've probably heard about melatonin. You can buy now in capsule form, and you can take it for various problems, such as sleep problems or jet lag and so on. And melatonin does a number of things. Among those, it regulates the estrous cycle in women. And it decreases in women, of course, as they age, and therefore causes some of the problems having to do with menopause. And some women take melatonin tablets in order to deal with some of these problems that they have when they age. And the major function is it regulates the biological clock. Okay, nictitating membrane. A nictitating organ is it's like a windshield wiper. Many reptiles have it, some birds have it, horses have it. And basically, it protects the eye against dust and rain and various things that impede it. It's transparent, so when it covers the eye, it not only cleans it, but it also protects it. And nictitate, the term itself, means to move rapidly back and forth over the eye. And in humans, it's basically all there is a fold of tissue, which they call a vestigial nictitating membrane. Well, now they recognize it has nothing to do with the nictitating membrane. Now they recognize, in fact, they gave it a new name. The name is the plica semiluminarius. And this new name, recognizes that it has nothing to do with the nictitating membrane. But it does aid in lubrication and to ensure effective eyeball movement because of where it's located. So it's kind of like a ball bearing, and when the eye moves back and forth, it allows the eye to be set properly and fit properly in its system, and it also lubricates so that the eye can move back and forth appropriately.
So it has no connection at all to the other animals that you talked about and the function that was in them. It's a whole different thing.
And if you look in the ophthalmology books, the textbooks in the area, all of them that I've seen recently properly point out that the two are not related.
Now, how long have we known that? When did the change in thinking come there?
Probably in the past 20, 30 years. The older books that I have still talk about it as a vestigial nictitating membrane.
And so the only reason it was called a nictitating membrane was because the worldview was that this is something we've inherited from other species.
Right. We inherited specifically from reptiles is what many books taught.
And when we got over that and looked at it as a part of our body that was made for us, then we were able to see, no, this has a whole separate function, has nothing to do with what's happening in other animals.
Right.
So perspective has a whole lot to do with what we determine, doesn't it?
Right. The research that we do in anatomy has a lot to do with our worldview. Creationists would see all organs as functional and necessary and try to find out what function they have. Where Darwinists saw a lot of structures as non-functional and not necessary, and therefore they said, well, they're vestigial, therefore why look to see what they do?
And so So the perspective kept us from scientific research that would have helped us better understand how our body works.
I think it did. I think Darwinism, in this case especially, interfered with.
This is a good example.
Trying to find out what structures indeed did. And I think that's why it's important to stress that it's really difficult to prove lack of function. You can't say it has no function. All you can say is we don't know what the function is at this time. And from a creationist perspective, we would say, well, what does it do?
And so if we assume that it does have a function, that's going to spur us on to do research that we wouldn't do if we assumed it had no function.
Right, to try to find out what the function is.
You know what, Dr. Jerry, we've got to take a break. And folks, don't go anywhere. We want to come back and we want to take this scientific knowledge that we've been looking at today, and we want to reach some conclusions about why, when we view life and the fact that God made us and He made every part of us and He made every part of us to function, that it changes how we study, what we learn, and really how we know ourselves better. So don't go away. Stay with us. We'll be back in a minute.
Creation versus evolution, you weigh the evidence. Saturn's rings, profound pictures. When space probes revealed pictures of Saturn, scientists were amazed at the appearance of billions of particles caught up in violent turbulence and instability in Saturn's rings. For these rings to have existed for supposedly billions of years, these particles should be in extremely stable orbits. If, on the other hand, the rings are only several thousand years old, what we see in Saturn's rings are consistent with known physical laws. Today's guest on Origins, Dr. Jerry Bergman, has been a featured speaker on many college campuses and at professional meetings throughout the United States and Europe. His research has been featured in many publications across the world. Dr. Bergman is also a professor at Northwest State Community College in the state of Ohio, where he has taught biochemistry, anthropology, geology, and microbiology. For more information about our guest, you can write to Dr. Jerry Bergman, Northwest State Community College, 22600 State Route 34, Archbold, Ohio, 43502.
Hi, my friends. Welcome back to Origins. I'm here with Dr. Jerry Bergman, and we've been looking at the organs in our body that we were told were vestigial, were unnecessary, and now we've found for every organ in the human body that there's a purpose and a function. And Dr. Jerry's been telling us about some of those and their functions, and he wants to come back now and kind of wrap up by talking to us about the problem of assuming that we have unnecessary parts.
Right, because that assumption drives research, and it drives how we see the world. And therefore, if our assumption is wrong, we could see the world in a way that we could distort what we find out or what we don't find out in this case. And it's a problem, too, because now we know these vestigial organs have functions. So what has happened is, instead of Darwinists admitting they were wrong, they've redefined what a vestigial organ is. Now what they say, a vestigial organ is an organ that is less useful in us compared to our ancestors. So they look at organs which were, they say, more useful in our ancestors, like the appendix, is more useful in rabbits, for example, because it also has a digestive function, and less useful in us, they claim. So therefore, they still try to argue, or at least some do, that it's vestigial. Most books, by the way, they just ignore this. Most anatomy books, you don't find this discussed at all. They just talk about the function of all the organs, and that's it. But some Darwinists, diehard Darwinists, still insist on keeping the idea and redefining it in such a way that what facts are available now fit their perception of reality.
I just am so grateful that you've been with us today. We're so thankful for men like you who have studied in the field of science and can bring us these specifics that confirm the truth that God has made us just as we need to be. That we are not the product of some evolutionary process, but that in fact we are the product of a great creator who has made us and has made every part of us with a purpose. Friends, you know, we've got a website, and you can download some of these programs and also some background material for the programs if you go to www.origins, that's origins with an S, TV.org. I hope you'll visit us there and find some information perhaps you need to buffet arguments that you have with those who still believe in evolution. And if you want to write to us, if you have questions and suggestions for other shows, write to us at Origins, care of CTV, that's Wall, PA, 15148. And you know, I just want to remind you that it's God's view that He created you. And that should be your world view too. God bless you until we see you next time. Good to be with you, my friend.
Thank you for watching this edition of Origins. If you'd like a copy of the information presented today, you can download a PDF file of program number 714 from our website at www.originstv.org or send $5 and write to Origins, program number 714, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.